Hello. So as Kirk mentioned, my name is Erica, or Sput is my handle, and I'm here to talk to you about security, specifically in the cloud and what that means. I guess to give you a brief background of who I am, welcome. I've worked in multiple different roles. I'm currently contracting as just a general security consultant, Jill of all trades, I suppose. But I've been previously an incident responder, leading the incident response team down at CERT New Zealand. I previously was a senior engineer down at Xero, working specifically on their platform security. Previously worked as a senior analyst, as an instructor, as a tester. So I've been around the whole plethora of different security roles. So if you ever have any questions, and I guess fun fact, I have an accounting degree. So perhaps you don't need formal qualifications to actually live out your passion if security is something that you're really into. But if you have any questions about what those different roles are like, because it takes different skill sets for each of those, feel free to come up to me afterwards, and I'd be happy to chat. So I'm basically a nerd. I previously, 2 years ago, was working for Xero as a senior cloud security engineer. And it's quite interesting. You see the term cloud used quite often, but it's not much different to how everything and all networks have kind of been operating. A lot of you might have been working for companies that have all of your internal systems across 2 different data centers spread throughout New Zealand or globally, and there's all sorts of networking components and hopes and dreams that kind of pairs and keeps those networks going. But the cloud is just kind of like a buzzword that started probably roughly around 2006 is when the pickup of that term kind of really took off. And basically where it stemmed from is some companies, like the large ones like Google and Amazon and Microsoft, kind of realized that they run these massive, large businesses, and they have all of these massive amounts of resources and computing power and really, really trained, skilled, technical people. We could probably commoditize that and sell it as a service. So that's where things like AWS, so Amazon Web Services, is the infrastructure that Amazon was built on to kind of run their whole online e-commerce platform. Shortly later, you had things like Microsoft Azure that was coming out. You had things like Google Cloud. So this kind of exploded over the past couple of years. So now you're kind of seeing things more specifically tailored towards cloud, but it really isn't much different from just being a network or a security engineer. Because even though we're kind of used to a lot of our stuff just being on premise, although it's moving to the cloud, it's not really all that different. And when it comes to shifting things from transitioning to the cloud or moving your systems or applications to cloud infrastructure, it kind of breaks down into multiple different levels of responsibility. Because if you think about Amazon and Microsoft and Google as some of the large cloud infrastructure provider players, they sell you a service to promise to do some things on your behalf, because perhaps you just want to pay them to do it because it's easier. They probably have better skills and resources to manage it anyways. So it kind of comes down to, cloud computing kind of comes down to this shared responsibility model. So this is a breakdown of the diagram from Microsoft, which kind of really explains the different types of cloud models that they'll sell you. So obviously, if you're hosting everything on premise, or that basically means you have all of your servers and your switching and networking that you look after yourselves, it's all your responsibility as a customer to make sure it's secure, make sure it's maintained, it's taken care of, and it's actually operating. But then as you kind of start shifting towards other types of cloud models, you're kind of in a sense paying and trusting that provider, like Amazon, to do them for you and do it in a good way. So when you move to infrastructure as a service, you're relying on places like Amazon to look after the physical security of the data center that your stuff is hosted in. And you're also kind of sharing responsibility around things like network controls and the actual host infrastructure or the server infrastructure you're building on. And then, of course, it goes another step where platform as a service, all the way through to software as a service, which is literally just stuff like, when you're using things like Xero. That's an accounting software as a service. So you can go onto a website, and the only thing that you have to do is subscribe to that software online, and all you have to really control is the data that you have yourself and how you protect that, and the access controls of who actually can access certain things. So that's kind of how it breaks down. And a lot of the people that have spoken over the weekend, we kind of talk about multiple different things when it comes to network security. You have things like WAFs and CDNs and host-based intrusion detection, IDS. Like there's a whole bunch of crazy acronyms that I myself still kind of get confused on. But the traditional model and the model of security architecture that a lot of you will probably be familiar with, or the type of architecture that you'll kind of be exposed to when you get your first job, is kind of like an onion, a happy little onion. But basically what it is, it's the concept of security in depth. So if you're going to be putting, and this is regardless of cloud infrastructure, it's just network architecture in general, you, at the very center of your onion, have your data. And ultimately, that's what you're trying to protect. That is like, the one thing in the core concept of security is making sure that that data remains intact, it is not shared with anyone who shouldn't have it, and that it's always there when you need it. And then you kind of build layers of defense, kind of like an onion, on the outside. So you add application security. So, are you actually coding the software following secure development practices? Following things like OWASP. And then you have the next layer. So the server or the host that software runs on, is it hardened? What type of security controls are you doing to protect that layer? And then at the very outskirts, you have your kind of like your barrier of defense, your network security. So what I'm going to go through is kind of talk through a few common concepts, specifically around the host security and the network security, and things that you might come across when it comes to looking at cloud infrastructure. So the first world we're going to get into is the host level security. So these are going to be the servers that are supporting and actually running your software. And one of the key things that you have to keep in mind, it comes around actually storage of your secrets. So your software is probably going to be making a whole bunch of API calls. It's going to be authenticating to multiple different services. You need to make sure that those, the keys that you're using and the secrets that you're using are protected. The last thing you want is to commit them to your GitHub repo, and all of a sudden you have your AWS secret keys floating on the internet for anyone to kind of pick up and use. And I have some links that once I publish the slides and share them with you, you can kind of read some of the stories that I've embedded through. But these are kind of really common practices because the concept of, I guess, using a public internet-based repository, you don't really think about some of these things. You don't think, oh, it's not too bad for me to just put in these AWS secret keys in this config file of my repo. But then when you publish it and put it in a public repo that anyone can see, you're going to have a bad time. Some solutions for being able to store your sensitive secrets are using things that are very usually cloud infrastructure specific. So you have things like AWS Parameter Store or Azure Key Vaults. I can't remember the one that Google Cloud uses, but it's something with probably parameter or key in the name. But basically what this is that it's kind of like having a password storage or like a lockbox within your cloud infrastructure. And you kind of assign the ability for different resources to look into that box and use that key, but it's fundamentally protected by encryption. And you're controlling it through different levels of access controls so that not anyone can look inside the box to take those keys. So that's kind of the first thing to kind of keep in mind. And you don't necessarily have to use any of those cloud infrastructure specific things. If you're running your own OpenStack platform, cloud infrastructure platform, so long as you're storing those keys, controlling it with access controls, and actually encrypting that data, that's basically what makes up those parameter store or key vault services. And then the next thing is multi-factor authentication. So you've heard it multiple times throughout the day today that MFA or multi-factor authentication is important. It is. It's very important to make sure that whenever you're logging in or accessing something, that you're making sure that the only people that can do that are the right people. So there's a whole bunch of different ways to be able to access your infrastructure or be able to, for example, SSH into your server, remote access into some of your boxes, and using some of these open source, I guess, plugins or PAM modules. So you have the Privacy IDEA, which is kind of an open source multi-factor authentication module, or even Google Authenticator have a whole bunch of guides online so that you can, in a sense, use Google Authenticator and get that one-time code that you get on your smartphone to be able to log in and SSH into your own servers. So super, super important, especially for the servers that are going to be internet-facing. because anyone can kind of knock on that door and see if they can get in. And then lastly, for host security, you have TLS certificates in decrypting traffic. So of course, you want the only person to be able to see the traffic that is going to your host. You want to make sure it's yourself and your actual client. So that whole path that they use to traverse the internet, the multiple different points of presence that you don't have control over, you want to make sure that the only thing that those people can see is a whole bunch of gobbledygook. And it's completely encrypted and protected. So of course, when it comes to TLS, you can easily roll out free certificates provided by Let's Encrypt. So those are quite simple to use. And then OWASP have a really great cheat sheet when it comes to which types of protocols and ciphers to use. Because like Kate mentioned, there's a lot of bad ones. So you want to make sure that you're using the ones that are up to date and haven't been broken yet. And sorry, one last one. One last more, is host-based monitoring. So this is basically the concept of kind of like having antivirus on your host, but kind of something that's a lot more advanced than your traditional old school thought of antivirus. So it's basically having, some of the models that you have for host-based monitoring is having kind of like a little agent sitting on your machine. So every time you spin up an image in AWS or in Azure, you embed this one piece of software that is kind of like a homing beacon. It will constantly monitor the state of that host. It will check all of the different software that is running, what versions are running. It will kind of ping back to a central point and say, hey, this host is currently running a really old, out-of-date version of Apache. You should probably know this because it needs to be updated ASAP. Or it can kind of alert you to a whole bunch of random things such as, hey, there's been a massive amount of attempts of SSH attempts on this box. You might want to come take a look at this. So it's a way to kind of, monitor all of your hosts at one central point. Because when it comes to cloud infrastructure, it is a bit different than managing your on-premise because you can spin up a server instantly. So you can have 100 different servers and be recycling them constantly. So the concept of, having cattle versus having, pets. So when it comes to cloud infrastructure, it's cattle because you're going to constantly be turning over these servers over and over and over again, depending of whether or not you're scaling up in size to support more traffic, or you're scaling down because it's a low point of the day. But either way, you want to make sure that every time you spin something up, that it's secure enough. And you can manage that from a central point, so you know exactly at any point in time which things are broken and which things are doing okay. And then in the next world, we're kind of getting to that higher level. So all the host-based security is kind of that inner layers of the onion. But if you wanted to kind of not rely on that as like your last point of defense, you you wrap something around the outside, which would be at your platform level. And one of the most important ones when it comes to platform level security is access, user, and role management. You probably see in the news all of the time around different types of AWS or Azure hacks and vulnerabilities and people leaving like really weak S3 buckets that are publicly exposed to everyone. You have API gateways that don't have proper controls and basically bypass every single other layer of network security because it's an open internet accessible endpoint to your whole entire network. So there's a whole bunch of really, really great talks out there by different security researchers kind of poking and prodding at these different types of services. But it all kind of comes down to the fundamental concept of just roles. So it gets quite complicated when it comes to cloud infrastructure because when you're having to manage all of your different servers and firewalls and other types of components, they all need access rights to run. So you have, in a sense, a whole bunch of service accounts that you have to control and manage to make sure that they're not talking to the components that they shouldn't be talking to, and they're only doing the things that they should. It makes sense that this grows out of control really, really fast. There was I think it was not the Equifax vulnerability, but I'm looking to Kate to see if she remembers. A few weeks ago, there was the AWS breach. Yeah, Capital One. Yes, thank you. So Capital One, that was caused by weak access controls and them not actually understanding what access rights they had given their web application firewall. So they're able to use that to send it commands to run at the back end and then return them the output at the front. So it all comes down to the fact that actually, Capital One, that's a really good example of how freaking complicated access controls can be. Because you don't really think about this, type of vulnerability when you're configuring them. So anyways, I guess long story short is that it's really, really hard. But there's a whole bunch of really good, white papers and research around how you can actually make sure that you're enabling them correctly from the start. But it all comes down to principle of least privilege. Don't give access to something if you don't have to. And if you're ever troubleshooting a P1 at 3 o'clock in the morning and you're giving something excessive rights because you just want to go back to bed, make sure you come back the next day and actually figure out what went wrong. Because those kind of configuration drifts happen in real life. And next thing you know, you realize that you've got an any rule on your firewall because someone made a really bad choice at 2 o'clock in the morning. Not speaking from experience. The next one is when it comes to platform security, also making sure that you're collecting and looking at logs. So, the concept, no logs, no crime. You always want to make sure that you're collecting information so that if anything goes wrong, you have something to fall back to actually understand what happened. This is really, really critical because if you don't have logs, you have no idea how this could have happened, and it could be a million different possibilities, and you're going to be kind of screwed. So there's a whole bunch of really good open source models. So you have things like Graylog. They have a paid service, but they also have an open source model, which basically works as kind of it's Elasticsearch, Logstash, and Kibana combination. So you're able to ingest all of the logs, do analysis, and actually produce dashboards. So it's really, really important and really, really critical to get stuff like this set up early because otherwise it gets very hard to do it after the fact. And then lastly, you have ingress and egress filtering. So this could be multiple different levels of things. This could be a web application firewall, which is ultimately, a WAF is just a reverse proxy that does some checking. And it will check for things like common security vulnerabilities. It will check for common web application, things like SQL injection and cross-site scripting. But ultimately, these components of your network are able to decrypt traffic and look at it and actually tell whether or not this traffic should be coming through. It can also be things like doing different types of rate limiting. So if someone is kind of hammering your platform with a whole bunch of malformed requests, you should be able to drop those and just kind of put them in the bin and just kind of carry on with all of your other traffic. But when it comes to ingress and egress security filtering like this, you really have to kind of start with nothing and slowly start to build your way up. When I was a senior engineer, it was a constant bugbear of mine that people in the community that weren't engineers thought that WAFs were this magical thing that were going to solve all of your security problems. When in doubt, put a WAF in front of it, which isn't true because you basically have to have the smarts to go through and pick apart every packet that's coming through and every single request to tell if it's bad. And if you don't have rules that can tell if it's bad, well, it's kind of useless. So a lot of them come with pre-built-in rules, or you can hire teams to create those rules for you. But it's important to kind of start from the bottom and build up. I think as well, I think some of the AWS and Azure built-in WAFs, they start with a really, really basic small set of rules that you can kind of start on. And then as you notice different vulnerabilities being attempted that perhaps you can't fix right away in your code, you can create unique rules to kind of prevent those things from coming through and ultimately protect that data in the center. And then lastly, you have everything else. So I know that wasn't a layer of the onion, but it's still kind of an important aspect. And there's one key part that can kind of sit on the edge of that. And that is a content distribution network. So content distribution networks, you're probably more familiar with them from more of a performance point of view. So basically you have points of presence or servers all over the world that will cache content so that it can have much quicker load times, especially for caching content for things like videos, images, and stuff like that. Stuff that you don't have to constantly go back to your web server to retrieve. It can kind of just sit on the perimeter. But it's also really important from a security point of view because these points of presence can also kind of, in a sense, it does increase your, I guess, your attack surface of your application, but it can also kind of absorb a whole bunch of crap that you get just by existing on the internet. So, it can absorb things and detect things like scanning or bot traffic. So when there's suddenly, all of a sudden, this creeping increase from the particular user agent, the CDN can shut that off at that CDN layer so that you're not going to start paying out the wazoo for your AWS fees because now all of these connections are trying to connect to your infrastructure. But it is kind of now getting at the CDN level, you're kind of sharing that responsibility with your CDN provider. So that could be someone like Cloudflare, it could be someone like Akamai, because you ultimately have no control over those points of presence and how those points of presence are secured, but you're trusting that vendor to actually take care of it for you. So it's kind of, in a sense, taking your shared model and like adding a third party. So now it's like a cloud security party, I guess. I don't know. I'm not really good at jokes. But I guess that's kind of at a high level. So a lot of these components that I've talked through, for those of you who have been network engineers or who have spent a lot of time doing networking, you're probably like, oh yeah, all of this makes sense. Like none of this is new. And that's it. Like there's nothing new about the cloud. It's just basically someone else's server that they've sold to you because they realize that, they're a lot better at managing it than you are, which is true in some cases. But yeah, so that's kind of the basic concept of, I guess, that defense in depth. But there are different types of models which will probably, as you're kind of going through uni and about to go into having careers, these models actually might kind of be more prevalent and more in use. So you have things that it's called zero trust architecture. So dumping that whole onion model, because it's nonsense, and I was trying to find a really cool comparison to an onion, but I just can't. But it's basically the concept of, instead of building layers and layers of security on the outside to protect your data, it's the concept of you trust nothing. Nothing is trustworthy, everything is a lie, and until that person can authenticate and prove to me that they are who they say they are, and I can check my little access control sheet behind me and be like, yep, Erica should be able to access this server because she has this access rights. That's the way those network models operate, which is, from a security perspective, quite fantastic because you no longer have these possibilities of failures from the outside. Like I mentioned, having a P1 at 2 o'clock in the morning and an engineer can just completely disable your firewall because they want to go back to bed. You're no longer relying on that model of having those multiple layers and then perhaps having them slowly start to fail over time. Instead, you're operating under the assumption that trust no one unless they can prove who they say they are. So it relies heavily on things like authentication and access controls, which means it's really hard to do. Because going back to the earlier point of the Capital One breach, it's simple in logic, but in theory, I suppose. But in practice, it's quite difficult. But if this is something that you're interested in reading about, there are really limited places in New Zealand that are actually looking at this type of model. So, not many, because it requires you to completely throw out everything and then start from scratch. But if this is something you're interested in, take a look at the Cloudflare blog. They have a really good detailed write-up of what it means, as well as the whole concept in the research paper by Google. It's called Beyond Corp. But yeah, that's pretty much it. Thank you very much. Go.
Oh, any questions for Erica? Who did her cool art?
Myself, when I was bored at work. Yeah? So a lot of companies do offer managed services, but if you're doing a side project, like a personal side project, you probably don't have a budget to pay for a managed security operations center. But yeah, a whole bunch of cloud service providers do offer bundled packages where you hire bodies on chairs to help you manage it from a day-to-day basis. So that would kind of be a managed operations center. From more of the security perspective, I think a few talks previously had mentioned the concept of a managed SOC, so a security operations center. So it would definitely be something that they would tailor. When it comes to, I guess, the larger providers like AWS and Azure and Google, I can imagine they probably charge a buttload of money for doing stuff like that. But you also have third parties that will sell that as well. So, you have consultancies within New Zealand that kind of offer their AWS experts, and you can hire them to kind of manage your AWS environment for you. So people sell it as a service as well. Yeah. Is anyone using real ID or tokens to verify people? I guess I'm not 100% sure what you mean by real ID. Do you mean like real me or?
Real me,
yeah.
yeah. You'd think that'd be really cheap to integrate into your website. Because you already paid for it with your taxes.
I think not that I'm aware of. I know, I think like Estonia, we're doing a whole bunch of stuff when it comes to like digital identities and stuff like that. But when you start getting into the public and having the public interacting as end users to your cloud infrastructure, you're going to have a bad time. Well, just because when it comes to dealing with the public, you have a large range of different types of accessibility and usability requirements. You have to basically accommodate everything from someone using a really old, out-of-date PC to be able to access their taxes, all the way through to very complex use cases. But I guess there are some government agencies that are looking at zero trust models for their enterprise or their internal networks, which means that their users would just basically be their employees. So I think, from my understanding, I think Orenga Tamariki are one of the agencies that they're kind of building that network from scratch and trying to follow as closely as they can a zero trust model. But a lot of other agencies will, I don't know, I think zero trust for government is probably at least 10 years behind once actual enterprises start picking it up. Yeah. Yep. With using, so what are the performance impacts of using zero trust against each of your server? There's definitely going to be a whole bunch of performance impacts, because if you think about the zero trust model, basically you no longer rely on the control. A common control for internal networks is that nothing is encrypted, because it's really too hard to manage your own internal certificates to make sure every single connection is going to be encrypted using TLS. You kind of assume that, well, if you've gotten through the first 2 layers of the onion, I'm going to trust that you're probably a good person, so you can see every bit of traffic that's on this network if you wanted to. So yeah, when it comes to using zero trust, and then for each individual server, they're going to have that computing time added for being able to decrypt traffic and also encrypt traffic for every single connection that they make. But then also you're adding on the performance of having to authenticate every single request that comes through to a central agent. So it is going to have performance impacts, but I guess perhaps you might be able to kind of gain some of those, you'll gain some performance by not having to run a whole bunch of those other types of security controls that you would commonly use. So it's kind of like a balancing game. But yeah, that's a good question.
Cool. Okay, last question.
So it comes back to the shared responsibility model. So running a firewall on a particular host, you're responsible entirely for the type of firewall it is, the actual ACL rules themselves, everything relating to, basically you're looking at more of like the infrastructure and the PaaS and IaaS. You're kind of responsible for a whole bunch of those upper layers. But when it comes to the actual anything from the the actual physical server itself that it's running on, the actual segregation of all of that computing power to yourself based off what you've requested, that's managed by Microsoft or by AWS. So it still comes back to that whole shared model. But what you put in your cloud infrastructure and what software you're running and how you've controlled access is entirely up to you. So they control the stuff on their side, but it's up to you to make sure that whatever you've spun up in your environment has been secured, if that makes sense. Yep.
Cool. Sorry to cut off here. We've got more talks coming up. So anyway, let's thank Erica for her wonderful talk.